Nahihirapan ka bang sagutan ang tanong sa iyong isipan? Pag-aaral wag pababayaan, kinabukas ay maaapektuhan. Aklat, module at internet ang naging sandigan. Dahil sa pandemyang nararanasan, edukasyo'y nahihirapan. Sinematematika, tayo na, eskwela taha. Sinematematika, may solusyon ang problema. Sinematematika, gising na, mag-aral na. Sinematematika, may solusyon ang problema. Nahihirapan ka bang sagutan ang tanong sa iyong isipan? Pag-aaral wag pababayaan, kinabukas ay maaapektuhan. Aklat, module at internet ang naging sandigan. Dahil sa pandemyang nararanasan, edukasyo'y nahihirapan. Sinematematika, tayo na, eskwela taha. Sinematematika, may solusyon ang problema. Sinematematika, gising na, mag-aral na. Sinematematika, may solusyon ang problema. Sinematematika, tayo na, eskwela taha. Sinematematika, may solusyon ang problema. Sinematematika, gising na, mag-aral na. Sinematematika, may solusyon ang problema. Sinematematika, tayo na, eskwela taha. Sinematematika, may solusyon ang problema. Sinematematika, gising na, mag-aral na. Sinematematika, may solusyon ang problema. May solusyon ang problema.
Magandang araw!
Good morning, students! Hello, Teacher Rob.
Hello, Teacher Aryan! How are you?
I'm good. How about you, Teacher Rob?
Well, Teacher Aryan, I'm so excited for today's episode because we are going to meet another new teacher discussant for our today's episode. And she will be sharing with us her expertise in teaching.
Wow, and I heard, Teacher Rob, that she is a cum laude from Davao del Norte State College, just
Wow.
like Teacher George.
Wow!
And she's a grade 9 teacher.
Like Sir George also.
Yes.
And now, without further ado, let us all welcome Teacher Joanna!
Dun, dun, dun! Dun, 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 dun! Teacher Joella cum laude! Teacher Joella, welcome to our Project CINEMATEMATIKA studio, our very beautiful studio of Panabo City National High School.
Hello, Teacher Aryan. Hello, Teacher Rab.
Teacher Joanna, how long have you been teaching here in Panabo City National High School?
Well, I've been teaching here for about 3.5 years, and currently I'm teaching STE and BEC students using blended and online modalities.
Wow, that's great, Teacher Joella. By the way, what is your lesson
elevation and angle of depression. And actually, Teacher Aryan and Teacher Ralph, it is one of the most exciting and interesting topic in Mathematics 9.
So are you ready, Teacher Joanna?
Yes, Teacher Ralph, absolutely yes.
So let us all watch this!
Good day, Matalinong learners! Magandang araw! Welcome in today's episode of CINEMATEMATIKA. I am Teacher Joella, your math buddy, and I am here to guide you in learning the different concepts and skills in Mathematics 9. Are your learning activity sheets ready? What about your pen and paper? Great! Let's begin a Math Dali and Math Saya lesson. In today's episode, you are expected to illustrate angles of elevation and angles of depression. Specifically, you will illustrate angles of elevation and angles of depression. Distinguish the difference between the angle of elevation and the angle of depression. And lastly, solve problems involving angles of elevation and depression. Before we proceed with our lesson for today, let us review first the 6 trigonometric ratios. In the right triangle, we can define the 6 trigonometric ratios. Consider this right triangle. Focus on angle B as our reference. The leg denoted by small letter A is the side adjacent to angle B. The leg denoted small letter B is the side opposite to angle B. And the leg denoted by small letter C is the hypotenuse of the triangle. Can you complete the 6 trigonometric ratios of the acute angle B using the lengths of the sides denoted by A, B, and C? I'll give you enough time to do so. Ready? Start! Time is up! Let's check your work. Did you get all the ratios correctly? Great job! I know you probably memorized the mnemonic device to easily determine the definition of the primary ratios, the sine, the cosine, and tangent. And what was that mnemonic device? Yes, the SOHCAHTOA. With that, you also easily define the 3 reciprocal ratios, which are cosecant, secant, and cotangent. I guess you're ready enough for our lesson. So let's get started. We have a flagpole here without a flag. It is mounted vertically but its base is fixed to the ground. Say a person named Ben is standing some distance away from this pole and looking straight at it. The line drawn from the eye of Ben to the distant point where Ben is looking is called the line of sight. This is the line of sight. Since this line is parallel to the surface, we call it the horizontal line of sight or simply a horizontal line. Now, if Ben is looking at the top of the pole, what would be the line of sight in this case? The line drawn from the eye to the top of the pole will be the line of sight. We see that this line of sight makes some angle with this horizontal line. This angle is called the angle of elevation. The angle of elevation of the top of the flagpole is simply the angle that this line of sight makes with the horizontal line. Let me repeat this quickly, as it's an important concept. When the person is looking up, the angle formed by this line of sight with the horizontal line is called the angle of elevation. Note here that the line of sight is above the horizontal line. Now what if Ben is looking at the base of the pole? What is the line of sight in this case? The line drawn from the eye to the base of the pole is the line of sight when Ben is looking at the base. In this case, the angle formed between the line of sight and horizontal is called the angle of depression. Yes, when a person is looking down, angle formed by the line of sight with the horizontal is angle of depression. Here, the line of sight is below the horizontal. So we can say that when the line of sight is above the horizontal, the angle of elevation is formed. But when the line of sight is below the horizontal, the angle of depression is formed. Here is a simple problem for you. This is to make sure that you understand this concept well. Suppose the girl, named Anna, is standing in a balcony of her apartment and looking straight at the neighboring building, which is taller than her apartment. When she looks at the top of the building, the line of sight is this one. And when she's looking at the bottom of the building, the line of sight is this one. And this is the horizontal line. Let us denote the angles that we see using some letters. Now, here is the question for you to answer. Which among these is the angle of elevation? And which is the angle of depression? Great! The angle of elevation is the angle P and is formed when she's looking up, and the angle of depression is angle Q, which is formed when she's looking down. Now, we will solve a few examples based on this concept. Problem number 1. A guy wire is tied to help support the tree while its roots take hold. An 8-feet wire is attached to the tree and to a stake in the ground. From the stake in the ground, the angle of elevation of the connection with the tree is 42 degrees. Find to the nearest tenth of a foot the height of the connection point on the tree. An illustration to this problem may look like this with triangle ABC. By looking at the illustration, you will be able to identify the known and unknown measures. An angle of elevation is measured 42 degrees from the horizontal line, which is the ground, to its line of sight. The variable C is the 8-feet guy wire tied from the trunk of the tree to the ground, which illustrates the hypotenuse of the right triangle. Commonly, the right triangle is represented by capital letter C, and the opposite to it is the hypotenuse, which represented by the small letter c. The variable A is the unknown side, which is the height from the tight guy wire on the tree to the ground. Commonly, a small letter denotes the opposite side of the capital letter represented by the angle. Since A is opposite to the given angle, and 8 feet is the hypotenuse of this right triangle, we will use the SOH, SO pattern, that is sine A equals opposite over the hypotenuse. We can simply write the following. Given are the measure of angle A, which is 42 degrees, and C, which is the hypotenuse, that is equal to 8 feet. The unknown is A, or the side opposite to the given angle A. The trigonometric function pattern to be used is sine A equals O over H, where O is the height, or A and H is the hypotenuse, that is 8 feet. Substituting the values to the function, we have the solution. Sine A equals A over C, that is sine 42 degrees equals A over 8. By cross multiplication, this equation becomes A equals sine 42 degrees times 8. Using your scientific calculator or table of values, we have A equals 0.6691 times 8. Then A is approximately 5.35 feet. Therefore, the height of the trunk from the guy wire to the ground is approximately 5.35 feet. In some cases, the unknown is the angle measured in illustration of angle of elevation and angle ladder leans against the wall. The foot of the ladder is 6 feet from the wall. The ladder reaches a height of 15 feet height of the wall. Find to the angle of elevation the ladder makes with the ground in hundredths place. So we will start by illustrating the problem. The sketch may look like this. Then we will identify the known and the unknown values. Given are A, or the height of the wall, the ladder reaches that is 15 feet, and B, or the distance between the foot of the ladder and the wall that is 6 feet. Now, what we're looking for is the measure of angle A, or the angle of elevation formed by the ladder and probably the ground. Now, what trigonometric function pattern should be used to solve the problem? With reference to angle A, the problem involves the values of A and B, which are its opposite and adjacent sides, respectively. Therefore, TOA is the applicable pattern. That is, tangent A equals opposite over adjacent. So the solution goes like this. Tangent A equals opposite over adjacent. So we have tangent A equals A over B. Substituting the values of A and B, we have tangent A equals 15 over 6. As I have mentioned a while ago, if the angle is unknown, an inverse trigonometric function will be used. Now, since the measure of angle A is unknown and tangent function is used, we will use the inverse function of tangent or arctan. In symbol, quantity tangent raised to -1. Tangent A equals 15 over 6 is now expressed as A equals tangent raised to -1 times 15 over 6. Again, using your calculator, express tangent raised to -1 quantity 15 over 6 by pressing shift or second function, then press tan, then open parenthesis, 15, then division symbol or quantity AB over C, then 6, close parenthesis. Lastly, press the equal sign. If you follow the steps correctly, the value is 68.20 degrees. A equals 68.20 degrees. Therefore, the measure of angle A or the angle of elevation is 68.20 degrees. I would like to emphasize that whenever measures of angles are unknown, inverse trigonometric functions are needed. The inverse function will depend on the trigonometric function you are using. If it's a sine function, then you will use inverse sine function or arc sine quantity sine raised to -1. For cosine function, that will be arc cos quantity cosine raised to -1. And tangent inverse function or arctan quantity tangent raised to -1. Alright, it is time to practice the skill we have just learned. Ready your paper and pen. All together, we say, Math the moment. Problem number 1. A woman is standing on the ground at a point 78 feet from the base of a building. The angle of elevation to the top of the building is 57 degrees. To the nearest foot, how high is the building? Go! Is up. An illustration to this problem may look like this. The given are the measure of angle A, which is 57 degrees, and the adjacent side, which is 78 feet. The unknown is the side opposite to the given angle of elevation or or the height of the building. The trigonometric function pattern to be used is tan 57 equals h over 78, where h is the height of the building. We have the solution tan 57 degrees equals h over 78. By cross multiplication, this equation becomes h equals tan 57 degrees times 78. Or using your scientific calculator or table of values, we have h equals 1.5399 times 78. Then, h is approximately 120 feet. Therefore, the height of the building is approximately 120 feet. How about this problem? Problem number 2. If a kite is 40 feet off the ground and the string holding the kite is 42 feet long, what is the angle of elevation to the kite? Alright, let's draw that picture. So here's the situation. The kite is 40 feet off the ground and the string holding the kite is 42 feet long. What is the angle of elevation to the kite? Based on this problem, the angle of elevation is the angle to the ground. To solve for the unknown angle x, inverse trigonometric function will be used. In the diagram, we have the opposite side, which is the altitude of the kite from the ground, and the hypotenuse, which is the measurement of the string holding the kite. So we will use the sine function. The sine of x is equal to opposite over the hypotenuse. Substituting the values, we have sine x equals 40 over 42. To find the angle x, we have to use the inverse function of sine. So we have x equals the inverse sine of 40 over 42. Using your calculator, x is equal to 72.247 degrees. This means that the angle of elevation to the kite is approximately 72.2 degrees. Problem number 3. From the top of a rock, 50 square root of 3 meters high, the angle of depression of a car on the ground is observed to be 30 degrees. Find the distance of the car from the rock. From the problem, we let BC be equal the height of the rock, the position of the car, which is in point A. The unknown side is side AB, which is the distance of the car, which is in point A, from the rock, which is in point C. Based on the illustration, we are dealing with the opposite and adjacent side. So we will use the tan theta equals opposite side over the adjacent side. Substituting the values of the angle and the height of the rock, we will have 50 square root of 3 times square root of 3. So AB is equal to 50 times 3, which is equal to 150. Therefore, the distance of the car from the rock is 150 meters. So, it has been a magandang araw and I hope today's episode has been very helpful. This is your math buddy, Teacher Joala, saying, math gives us hope that every problem has a solution. See you again next time as we face, overcome, and befriend the challenges ahead.
Nahihirapan ka bang sagutan ang tanong sa iyong isipan? Pag-aaral wag pababayaan, kinabukas ay maaapektuhan. Aklat, module at internet ang naging sandigan. Dahil sa pandemyang nararanasan, edukasyo'y nahihirapan. Matematika, tayo na, eskwela taha. Matematika, may solusyon ang problema. Matematika, gising na, mag-aral na. Matematika, may solusyon ang problema. Nahihirapan ka bang sagutan ang tanong sa iyong isipan? Pag-aaral wag pababayaan, kinabukas ay maaapektuhan. Aklat, module at internet ang naging sandigan. Dahil sa pandemyang nararanasan, edukasyo'y nahihirapan. Matematika, tayo na, eskwela taha. Matematika, may solusyon ang problema. Matematika, gising na, mag-aral na. Matematika, may solusyon ang problema. Matematika, tayo na, eskwela taha. Matematika, may solusyon ang problema. Matematika, gising na, mag-aral na. Matematika, may solusyon ang problema. Matematika, tayo na, eskwela taha. Matematika, may solusyon ang problema. Matematika, gising na, mag-aral na. Matematika, may solusyon ang problema.